Lesson 1.8 is on rates, ratios, and proportions. So in this lesson today, we're going to be looking at ratios, which is the comparison of two quantities by division. So the ratio of A to B can be written as A colon B or A over B, where B does not equal 0. So a lot of times you'll see ratios written in the fraction form. Sometimes you'll see it with a colon as well. Ratios that name the same comparison are said to be equivalent. Just like you can have fractions that are equivalent, we can have ratios that are equivalent. It just means that they represent the same value. So a statement that two ratios are equivalent, such as 1 over 12 equals 2 over 24, is called a proportion. So when we have two ratios that are equivalent, they're called proportions. So we're going to be looking at rates, ratios, and proportions today. So we're going to start by looking at example 1. Example 1 says the ratio of faculty members to students at a college is 1:15, or 1 to 15. There are 675 students. How many faculty members are there? So it says the ratio of faculty to students is 1 to 15. So that means this 1 represents faculty, and the 15 represents students. So I'm first going to write this as a fraction, okay? And again, we're dealing with faculty and students. Order is really important when we talk about ratios. So faculty is 1, so it's going to be 1 over students is 15. Now we know that there are 675 students. So students is 675. So I'm going to keep that in the bottom of my fraction. And we want to go find how many faculty members. So here we can just write an equivalent fraction. Okay? How do I go from 15 to 675? Okay, we have to figure out what we need to multiply there. How many times does 15 go into 675? So you can do 675 divided by 15, and you'll see that it's 45. So if I multiply 15 by 45, we get 675. If I multiply the bottom by 45, I can multiply the top by 45 to get an equivalent ratio or an equivalent fraction. So 1 times 45, 45. So to answer the question, how many faculty members are there? The answer would be 45. 45 faculty members. There is a check it out problem for you to try, so go ahead, pause the video and try this one on your own, and then resume when you're ready to check your answer. So it says the ratio of games won to the games lost for a baseball team is 3 to 1. So it's 1 to lost. So 3 represents the wins, 2 represents the losses. The team won 18 games. So how many games did the team lose? So I'm going to do wins, losses. And I'm going to write my ratio to start as a fraction. So we have 3 wins over 2 losses. Now you can flip the top and the bottom if you want. If you want to write losses and wins, that's fine, as long as you're writing the correct number that goes with the correct representation there. So I have won 18 games. So winning up top. So 18 is going to go up top. So now I need to figure out, how do I go from 3 to 18? Well, 3 times 6 gives me 18, so I'm going to multiply the bottom by 6. 2 times 6 gives me 12. Okay, so how many games did the team lose? The team lost 12 games. And like I mentioned before, you could switch this, so you could have losses in the top, wins in the bottom. You would just have 2 over 3. Okay, and then wins in the bottom, so 18. and then you multiply top and bottom by 6 like we did up there. So you would still get 12 games. As long as what's on the top stays consistent, so losses and losses, wins, wins, okay, you can switch the top and the bottom. Now we're going to go ahead and look at example 2. Okay, so a rate is a ratio of two quantities with different units. So before we were looking at games. Okay, let me move this down so you can see it. So a rate is a ratio of two quantities with different units. So miles per gallon. We have miles and gallons. So rates are usually written as unit rates. And a unit rate is rate with a second quantity of a unit of 1. So miles per gallon, where we have 17 miles per 1 gallon. So you could write that as 17 miles per gallon. And you can convert any rate to a unit rate. A lot of times when you go grocery shopping, you'll see that it's the rate per pound, how much something costs per pound of that unit. So here in this first example, it says, I'm not sure how to pronounce this name, but of Japan, he ate 53.5 hot dogs in 12 minutes to win the contest. So every year they do a hot dog eating contest. So you probably have seen that on TV. I think it's around 4th of July. But he ate 53.5 hot dogs in 12 minutes. So we want to find the unit rate of hot dogs per minute. So that's going to be per 1 minute. And that's where this unit rate is going to come into play. And then we're going to round to the nearest hundredth place. So we have hot dogs. So I'm going to write hot dogs. And then we have minutes. You should notice that these are two different units of measure, so this is going to be a rate. So we have 53.5, and that is in 12 minutes. And we want to get for 1 minute. Okay, we want to see how many hot dogs he can eat in 1 minute. So to go from 12 to 1, we're going to divide top and bottom by 12. And that will give us how many hot dogs are eaten in 1 minute. So you're going to do 53.5 divided by 12, and that'll give you 4.45. So 4.45, 8, and then the 3 is going to be repeating. Now it says to round to the nearest hundredth place, so we're going to round that to the nearest hundredth place. Hundredth place is your second number behind your decimal. So 8 is above, so we'll give it a shove. So we'll say 4.46. And the label for this is hot dogs per minute. Okay, and it's hot dogs per 1 minute. That's why it's a unit rate. 1 minute means a unit rate. Okay? There's a check it out problem for you to try. Corey earns $52.50 in 7 hours. Find the unit rate in dollars per hour. So go ahead, pause the video and try this problem on your own. All right, so we have $52.50, 7 hours. We want to find dollars per hour. So we're going to go to 1 hour. So we have dollars, and we have hours. So we have $52.50 in 7 hours, and we want to get dollars per 1 hour. So we want to get our hours to become 1. Let me get my focus back. Sorry about that. And then I'm going to divide top and bottom by 7. So 7 divided by 7 gives me 1. Up top, we have to do 52.50 divided by 7, and that will give us 7.50. 7.50. So what this means is $7.50 per hour, and that would be our unit rate. Now we're going to look at example 3. This deals with dimensional analysis. So dimensional analysis is a process that uses rates to convert measurements from one unit to another, such as 12 inches is 1 foot. So we might have to convert from inches to feet or feet to inches. So a rate such as 12 inches over 1 feet in which the two quantities are equal but uses different units is called the conversion factor. Okay, so 12 inches in 1 foot is called the conversion factor. To convert from one set of units to another, multiply by a conversion factor. So in these examples, we are going to have to convert to different units first, and then we will use that information to convert to a unit rate, or we might have to write an equivalent rate. So A, it says a large adult male human has about 12 pints of blood. Use dimensional analysis to convert this quantity to gallons. Okay, so first, okay, we're going to have to do a couple of steps here. If you know how many pints are in a gallon, you can go right there. But if not, I'm going to first go from pints to quarts. So I have 12 pints, and I know that there is 2 pints in 1 quart. So I have 1 quart, and it is 2 pints. So I'm going to multiply these. So I'm just going to put 12 over 1, because that still equals 12. When you do these, you want your units to cancel out. So pints and pints will cancel out. So now you're just left with quarts. So we have 12 times 1 is 12, so 12 quarts. And then 1 times 2 gives us 2. So 12 divided by 2 will give us 6. So now we have 6 quarts. So we know 12 pints equals 6 quarts. So now we're going to go from quarts to gallons. So we're going to take what we just found, this 6 quarts, and we're going to change it to gallons. So 6 quarts. And I know that there are 4 quarts in 1 gallon. So 1 gallon equals 4 quarts. So 1 gallon over 4 quarts. So I am going to again put 6 quarts over 1, and I'm going to multiply. The quarts cancel out on the diagonal, and I multiply across. 6 times 1 will give me 6. So I have 6 gallons, and then 1 times 4 will give me 4. So I have 6 gallons over 4. Okay, and 6 over 4 will equal 1.5. So 1.5 gallons is equal to 12 pints. Now there's a part B. Okay, here we have a seahorse, and it swims at a rate of 52.68 feet per hour. We're going to convert this speed to inches per minute. So we're going to have a lot going on here. Okay, so first, okay, let's deal with the feet to inches. So what I like to do is we have feet per hour. Okay, and I'm going to write this as a fraction. So we have 52.68 feet, and it's per 1 hour. And we want to change it to inches. Okay, so now we're going to go for inches per hour. Okay, so to go from feet to inches, we know that there's 12 inches in a foot. So I'm going to multiply this by 12. The hours are going to stay the same because we're just changing the units of our feet to inches. We're not changing the quantity of what we have. So hours will still stay the same. So I have 1 hour. So up top, I'm going to take 52.68, and I'm going to multiply that by 12. Okay, so we get 632.16. 6. Now I need to go to minutes. So I have inches already. And now I need to go to minutes. So we have 1 hour. There's 60 minutes in an hour. So I'm going to multiply this by 60. Okay. So my inches will stay the same. Okay. Inches are staying the same. So up top I'll have 632.16. The only thing that changes is the hours to minutes. So 1 times 60 will give me 60. So I know inches per minute, or how many minutes right now, not per 1 minute yet. We're going to get there in a moment. But we have 632.16 inches for 60 minutes. And now I want to get to just 1 minute. So my units are all correct now. And now I'm going to go to that unit rate. So to go from 60 to 1, I'm going to divide by 60. And I'm going to divide the top by 60. Because now that we have the correct units, we have to get our unit rate. So what we do to the top and bottom has to be the same. So now we're going to do 632.16 and divide it by 60. And you get 10.536. Okay, so that means we have 10.536 inches per minute. So our unit rate is per 1 minute. So 10.536 inches per minute. All right, there is a check it out problem for you to try. A cyclist travels 56 miles in 4 hours. Use dimensional analysis to convert the cyclist's speed to feet per second. Round your answer to the nearest tenth and show that your answer is reasonable. So go ahead and pause the video. Try this one on your own. Resume when you're ready to check your answer. So 56 miles, 4 hours. So I'm going to start. I have miles and hours. So I have 56 miles in 4 hours. And we want to get to feet per second. Okay? So miles, I'm going to be going to feet. And I know that there are 5,280 feet in a mile. So I'm going to multiply this by 5,280. So I'm going to do 56 times 5,280. And you're going to get a really big number here. You're going to get 295,680. Okay? So that's how many feet are in 56 miles. Now I want seconds. So to go from hours to seconds, okay, there's 60 minutes in an hour, 60 seconds in a minute. So that means in an hour, 60 times 60 gives us 3,600 seconds in an hour. So we're going to multiply this to get our seconds. So 4 times 3,600 is 14,400. Now we're changing this again to feet per second, so I need to get 1 second. I need to get 1 in the bottom. So that means I'm going to divide by 14,400 to get my 1, and I'm going to divide the top by 14,400. So we have 295,600, and we're dividing by 14,400. And that's going to give us 20.53, and that's 3's repeating. Okay? It says to round to the nearest tenths place, so tenths is your first decimal place. 3 is below, so we'll let it go, so we'll leave it as 20.5. So it's going to be 20.5 feet per second. So my unit rate is 20.5 feet per second. So now we're going to look at some cross-product property examples where we have a proportion A over B equals C over D, where the product of A and D, okay, when we cross multiply, is going to equal B and C. So those are called cross products. So we're going to solve examples where we cross multiply and then solve an equation. So that's going to be example 4. So for the first one, we have 5 over 9 equals 3 over W. We're going to solve for W. So we're going to cross multiply. So W times 5 will give us 5W. And then we're going to do 9 times 3. And 9 times 3 will give us 27. Then we're going to solve for W. So we'll divide both sides by 5. 5 divided by 5 is 1. So we're left with W. And then on the right-hand side, 27 divided by 5 gives us 5.4. So W equals 5.4. Example B, we have 8 over x plus 10 equals 1 over 12. So we're going to cross multiply here. So we're going to do 12 times 8, and 12 times 8 gives us 96. This time we have a quantity here. Whenever you have a quantity, you want to think of it in terms of being in parentheses, because whatever this is, we're going to multiply the whole thing by 1. So here we're going to have 1 times the quantity x plus 10. Okay, and then we would distribute. So 1 times x is 1x plus 1 times 10 gives me 10. So I have 96 equals x plus 10. And then I would subtract 10 from both sides. 96 minus 10 gives us 86. The plus 10 minus 10 gives us 0, so we're left with x. So x equals 86. There are 2 check it out problems for you to try. So go ahead, pause the video, try these 2 on your own, and then resume ready to check your answer. All right, the first one. We have 8 times negative 5 gives us negative 40. 2 times y gives us 2y. Then we're going to divide both sides by 2. Negative 40 divided by 2 gives us negative 20. Equals 2 divided by 2 is 1, so we're left with y. So y equals negative 20. For B, we're going to have 4 times the quantity g plus 3. So 4, and then in parentheses, this g plus 3 equals 5 times 7. And 5 times 7 is 35. Left-hand side, we're going to distribute that 4. So 4 times g gives us 4g, plus 4 times 3 gives us 12. So we have 4g plus 12 equals 35. And then we're going to solve this 2-step equation. So subtract 12 from both sides. 12 minus 12 gives me 0, so I'm left with 4g equals 5 minus 2 is 3. 3 minus 1, 2. And then I have 4 times g, so I'll divide both sides by 4. 4 divided by 4 is 1, so we're left with g. And then 23 divided by 4 gives us 5.75. So whenever you have a two-term expression, you want to make sure you put it in parentheses so you properly distribute this 4 to each term when you multiply. All right, example 5. We're going to deal with some scales. So a scale is a ratio between two sets of measurements, such as 1 inch, 5 miles, 1 inch to 5 miles. A scale drawing or scale model uses a scale to represent an object as smaller or larger than the actual object. A map is an example of a scale drawing. So when you deal with maps, maps are really, really small compared to the land that they're representing. So 1 inch here represents 18 miles. So part A, it says on the map the distance from Chicago to Evanston is 0.625 inches. What is the actual distance? So here we know on our map 1 inch represents 18 miles. So we write that as a fraction. Okay, so we have the map over the actual distance. On the map, we have 0.625. We don't know the actual distance, so we're going to write that as x. So we have these two fractions equal to each other. Then we're going to cross multiply. We have 1 times x, which is 1x, or x times 1. And then we have 18 times 0.625. X times 1 is 1, or 1x. And then 18 times 0.625 will give us 11.25. So the actual distance is 11.25 miles. Part B says the actual distance between North Chicago and Waukegan, I'm not sure if that's how you say that, I'm not very familiar with this area, but 4 miles. Okay, so the actual distance between those two cities is 4 miles. What is the distance on the map? Round to the nearest tenth. So again, our scale is the same. The map represents 1 inch, actual distance is 18. So 1 over 18. So we have the map and the actual. So 1 to 18. On the map, we don't know the distance, but we know the actual distance this time is 4. So actual goes in the bottom. So now we cross multiply. 1 times 4 gives us 4. 18 times x gives us 18x. And then to get the value of just 1x, we're going to divide both sides by 18. 4 divided by 18 is about 0.2. So on the map, 0.2 inches. There is a check it out problem for you to try. It says a scale model of a human heart is 16 feet long. The scale is 32 to 1. How many inches long is the actual heart it represents? So pause this video, try this one on your own, and then resume it when you're ready to check your answer. So we have the scale and the actual here. So that is 32 to 1. Okay, scale you can also think of as the model. Okay, we know the model is 16 feet. So this equals 16. I want to know how long the actual heart is. And this is going to be in inches. Right now we're talking about feet. So we're going to have to do a conversion at the end. So now we're going to cross multiply. So we have 32x equals 1 times 16, which gives us 16. Then to get the value of 1x, we're going to divide both sides by 32. 32 divided by 32 is 1, so I'm left with x. 16 divided by 32 is 0.5, or 1/2, and this is feet. To get to inches, we have to multiply by 12. So 12 times 0.5 will give us 6. So our final answer is 6 inches.